This recording is for blood transfusion model, and I am Shoven Shrivastava. I have built this model for the midterm project for time series course. Donating blood is very important and novel cause, and good data driven system can be used for tracking and predicting donations, and supply needs can be improved for the entire supply chain. So I'll first start with talking about the data set and uh, uh, and uh, and how many variables we have. So we have four variables. It's a pretty simple data set. We have four independent variables and one dependent variable. Therefore, independent variables are months since last donation, number of donation, total volume donated, and the month since the first donation. We have to use these independent variables to predict the made donation, uh, to predict a variable called made donation in March 2007. I first started with doing a summary on the training data set and to see how this data, like how these variables are distributed. And then I did a lot of EDA. The first thing that I did in the EDA is to learn the pair command, so that I can see uh, so that I can see the relation between the variables. And as you can see, there are some categorical variables, and there are some variables which are very linear, like related to each other. Then I did a box plot to see which variables has outliers, and it seems that the number of donation has lot many outliers, and total number of volume in CC have lot number of outliers too. Then I did a histogram to see how these variables are distributed, and based on this histogram, I decided to transform the I decided to transform the volume donated in CC uh, to uh, uh, to log transform variable, so that it has the same scale as the other variables. So that's the only transformation I did for the whole model. Then after transforming the variables and after doing the EDA, I decided to build the model. I chose four models because since the outcome is binary and it's more of a classifier than anything else, so I chose the first one is the logistic model, second one is the decision tree, third one is LDA and SVM, and the first model. So the first model that I built is logistic and using the binomial regression, and it gave me a pretty good accuracy of 0.7083. AIC was low, BIC was also low, and then I built a decision tree which gave a which gave accuracy of 0.7153. So first I divided the training data set into training and the validation data set, and then I have a test data set. So I built my model on the training data set and saw the accuracy like on the validation set, and that's how I have calculated the accuracy. So for decision tree, I got the accuracy of 0.7153, and for LDA, I have the accuracy of 0.7222. It seems that LDA gave me the best accuracy, so I decided to run LDA regression model into in my test on my test data set, and my model performed well. I submitted the result of the model uh, in the driven data set website, and I got the ranking of 82. uh, I think I can do some more transformation to improve these results, and so mostly I can run a box Cox this model to see uh, how we can how I can do more more transformation and run the model uh, uh, with those transformed variable. That will definitely improve the analytics accuracy, but I will do those things in the future. um, so that was the whole model. Ultimately, I think it's the LDA model which performed the best. Thanks.